And what are the different types of state space representations? Basically, we can classify the representation as three types. One is the state space representation using phase variables, and using canonical variables, and using physical variables. So these are the three types of state space representations. Let us start with phase variable representation. So state space representation using phase variables. Again, in phase variable there are two types. One is controllable canonical form, the other one is observable canonical form. The very famous term is CCF, controllable canonical form, OCF, observable canonical form. So these two forms also called series decomposition methods, because we are going to connect all the integrators in series in both the canonical forms. Therefore it is also called series decomposition methods. Now in that, let us take the first one, which is CCF form, controllable canonical form. So let us take the transfer function in polynomial form. So the output is, let us say, y, the input is u. So I can write y of s by u of s is equal to, it is a ratio polynomial. The numerator is, you have bn s power n plus bn minus 1 s power n minus 1 and so on, and lastly plus b naught. So this is a numerator polynomial. So divided by, in the denominator polynomial, I have s power n plus a n minus 1 s power n minus 1 plus dot 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 up to a naught. So when you look at this transfer function, in the denominator, the first term s power n, the coefficient is 1, and this is a one standard form. So whenever you take the control canonical or observable canonical, see that the coefficient of the denominator highest degree is always 1. Now, so once this is available, what I want is, now I want to write y by u, let us say it is y by u, as a two different distinct. One is y by x1 and x1 by u. So y by x1, what will be the y by x1? So I have a numerator denominator. Let us take the numerator is y by x1. So I can write here y by x1 as bn s power n plus bn minus 1 s power n minus 1 plus dot 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 up to b naught. And when you write y, so y is equal to, so these terms into x1. So how can you write this equation now? So y is equal to, already bn s power n we have into x1 plus bn minus 1, and we have s power n minus 1 into x1 and so on, lastly b naught x1. Let us say this is equation 1. So this equation gives the output, because the left hand side we have y, which is the output. What is the second one? The second one is x1 by u. So how can you write the x1 by u? The remaining is the denominator. So I am taking x1 by u is equal to 1 over, what is the denominator? S power n plus a n minus 1 s power n minus 1 plus dot dot up to a naught. Then if you cross multiply, then you will be getting u as u is equal to, so when you cross multiply these two, then you will be getting x1 into this entire equation. So what will be that? We have already x power n and into x1 plus we have a n minus 1 x power n minus 1 into x1 and so on. Now in this equation, what I want to write here is, I want to write this x power n separately. So x1 into s power n is equal to, when you take this equation the other side, u minus the remaining term, that is you have a n minus 1 and s power n minus 1 x1 plus, and so the last element will be x1 into a naught. So this is equation number 2. So equation 1 is of the y, equation 2 is of x power n, x into s power n. So let us take, for simplicity purpose, the order is 3. N is equal to 3. When you take n is equal to 3, then these two equations can be modified. So when you look at the first equation, the y is equal to b3s cube x1, bt s square x1 and b1 x1 plus b1 s x1 plus b naught x1. This is equation 3. So wherever n is there, I am replacing with 3 so that I am getting this equation. Similarly, equation 4. Equation 4 we can write from equation 2 by substituting n is equal to 3. So what is the left hand side? Earlier it was x power n into x1. So now s cube x1 is equal to u minus a2 s square x1 minus a1 x s x1 minus a0 x1. So this equation right hand side by u and also all minus terms with again x1. Equation 3 and equation 4. Using equation 3 and equation 4 we can build the block diagram.